Okay, ladies and gentlemen, this is another guided notes video. So basically, if I write it, you write it. So we are learning how to use displacement versus time graphs, like you've been dealing with in the matching motion activity, to calculate speed, distance, and displacement. Here we have an object that starts at 0, goes to 4 meters away, and takes 2 seconds to do that, then stays at 4 meters from 2 seconds until 7 seconds, and then at 7 seconds goes quickly back to 0. All right? And so we are going to take notes on this graph and also to solve problems here. So if I write it, you write it. Okay, so number one, what is the total distance covered? Show your calculations. All right, so the segments that we have here, we call these segments of a line. So we have segment OA, it's that one, okay? And so I'm going to look at the distance for OA, and then I'm going to look at the distance for AB, and then I'm going to look at the distance for BC. All right, so OA, AB, BC. And so basically what I'm going to do is I'm going to put this in a way that should make sense for everybody. I'm essentially going to do a where do I start? Where do I finish? Okay, so at OA, I start at 0 and I finish at 4. So I start at 0 and I finish at 4. That means I have traveled 4 meters. At AB, I start at 4 and I finish at 4. So therefore, I am traveling 0 meters. And BC, I start at 4, I finish at 0, therefore I have traveled 4 meters. So my total distance is going to be those things added together. So total distance is equal to 4 plus 0 plus 4 is equal to 8 meters. All right. Number 2, what is the displacement at point C? Well, remember, displacement is your overall change in position. So I'm simply going to ask myself again, where do I start? Where do I finish? So I go back to my graph. Where do I start? I start at 0. Where do I finish? I finish at 0. Finish at 0 meters. So my displacement is 0 meters. All right. Now, I don't necessarily like that. Let's do it like this. There we go. My displacement is 0 meters. Okay, now on to speed of the object in segment OA. have to wrap your head around is that you actually already know how to do this, okay? Speed on a distance time graph like this is the slope of the line, because the slope of the line is change in y over change in x, and that's going to give you y is meters, x is seconds, so that's going to give you units of meters per second. Now, just to make sure that I don't confuse anybody, I think I'm going to not use m for slope. I think I'm just going to write out the word slope. There we go. And that is the units. Well, what do you do to calculate slope? Well, you do what we've always done to calculate slope. You go in and you figure out for this point, what is your x left and what is your y left? Well, as it turns out, you're at 0 on the x and you're at 0 on the y, so that's pretty easy. X left is 0 meters, y left is 0, not 0 meters, x is seconds, 0 meters. Then you go up here to A, because this is the OA segment, and you find the x right, y right. Well, x right is 2 seconds. Y right is 4 meters. Now we're going to take those and put them into our calculation. Our calculation is always delta y divided by delta x. Delta y is y right minus y left so let's get those. Y right was 4 meters, y left is 0. So 4 meters minus 0 meters. Delta x is x right divided by x left. So we go back to the graph. X right is 2 seconds, x left is 0 seconds. 2 seconds minus 0 seconds. That gives you 4 meters over 2 seconds. Put that into your calculator and you will get speed for segment OA is equal to 2 meters per second. And you need to have the meters per second, okay? That unit is important. Next, what is the speed on segment AB? Well, basically, you can do it the same way. You can do x left, y left, x right, y right, or you can simply say it started at 4, it ended at 4, there was no motion at all. So your speed for section AB is 0 meters per second. And the reason, of course, that you know that is that it started and finished at 4 meters, so no movement. finally, what is the speed of the object on segment BC? So let's switch colors here so that we don't get confused. All right, so BC, so segment BC is here. Now, notice we're going down this time, okay? And that's going to show up in our calculations. But we're going to do everything exactly the same way as we did before. We're going to do an X left, Y left. Okay, X left is 7 seconds. Y left is still 4 meters, is what it was before. Then we're going to do an X right, Y right, because this one right here is to the right of the first one. Okay, so that's my X right, Y right. So my X right, of course, is 8 seconds. My Y right, of course, is 0 meters. So I'm going to go do exactly, excuse me, the same thing that I did before. My speed is going to be delta Y divided by delta X. That's going to be Y right minus Y left, which is going to be Y right is 0, Y left 4 meters. So it's going to be 0 meters minus 4 meters. So that is going to turn us negative. Then we're going to divide that by X right minus X left. So that's going to be X right, 8 seconds, X left, 7 seconds. So 8 seconds minus 7 seconds, that's going to be negative 4 meters over 1 second. So my speed is going to be negative 4 meters per second. Okay, now a couple of things about this, all right, which I'll put in purple here. Okay, the first thing is that right there is the steepest slope. So notice that is way steeper than that. So that means that's the fastest speed. That right there, flat, is equal to no slope, or slope equals 0, which means 0 meters per second, right? No movement, speed is 0. And this right here is the shallowest slope. So that's the slowest speed when moving, of course, because obviously 0 is even slower than that. Now, the last thing to point out here is that you have a positive speed here. So that means you're moving away from the start. So you start at 0, you go to 4th, that's positive speed. Over here, you have a negative speed, which means you're moving toward the start. So you're at 4, going back to 0. All right, well, that's everything that we have for those. You'll use that in the next part of the activity. Good luck.